Welcome to the Solchain demonstration. In this video, we will explore our blockchain-powered peer-to-peer solar energy trading platform built for Bangladesh and beyond. Our user interface is built with React.js, providing fast and responsive experience for prosumers, consumers, and validators. We use Web3.js to connect frontend directly to the Ethereum blockchain, enabling real-time wallet management, energy trading, and governance. Our backend is built with Node.js and Express.js, providing robust RESTful APIs for all blockchain operations. We use Hardhat for smart contracts development, deployment, and testing, ensuring reliability and security. The backend integrates directly with the blockchain using modular function calls. All wallet management, token operations, and marketplace logic are handled in the backend for auditability and compliance. Let's start the Hardhat node first. Now let's start the backend server. Now we will start the frontend server. And finally, we will start the AIML model. The backend server is already running and the Hardhat node is already running. We have to deploy the contracts. The contracts are deployed successfully. And now we have to test if the contracts are properly deployed or not. It passed all the tests, so the contracts are properly deployed. Now, if we wish, we can visit the web version. So let's first visit the web version. Here we can see the web version and we can log in with our credentials. We have successfully logged in. There is another option to use the Android version. So let's do that. To use the Android version, we have to scan this QR code. We can use our credentials here to log in. As we enter, we can see the dashboard. In the dashboard, there are multiple options to buy, sell, stats, community settings, and everything. There's energy overview, recent activities, and my goals and everything. So let's get started with the buy option. The users can list their energy for sale. So we can see a couple of listings here. We can buy them. So let's try buying one. We have successfully bought energy from an user. And simultaneously, we can see that the chain is getting updated. We can also sell the energy. Currently, the sell mode is off, so my listings are not in the listing. We can turn the sell mode on. Let's try turning the sell mode on. My sell mode is currently on. Now I can list my energy for sale. Let's say I'm going to sell 2 kilowatts of energy, and I will accept the market rate that is being generated with the ML model. So let's sell. The offer is successfully created, and the offer is listed in the blockchain. So we have also the statistics of all the energy, like total savings, energy saved, carbon offset, the weekly usage generation, P2P breakdown, sold, bought, monthly earnings, transaction statistics, energy transactions, and everything. We have the community over here where we can see multiple options to trade with, and everything. Then there are settings. This is very basic. We can do our settings here. I can see my wallet address here. I can turn the notification on and off. There are news updates, transaction alerts. In the notification option, we have the option to see this listed sale and the purchase I just made. These are two transactions I just made. We have the option to change the language to Bengali to English. Then we have the energy overview. If we enter the energy overview, we will see the ML generated energy overview. The real-time metrics are being generated from the ML model. The predictive analysis, the battery status, and grid status, everything is coming real-time from the smart meters or the ML model. We can see the energy flow, the historic data, weather forecast, carbon footprint, and everything. We can also export the summary in a form of PDF. Here's the dashboard. We can save it as PDF. Then we have the recent activities where we can see our recent transactions. We can also convert our Solar token into cash with Bcash or Nagad, or we can buy with Bcash, Nagad, and other payment gateways. Then we have our goals where we can set our monthly goals and other things. This is everything about our app. Now let's move on to the next section. I will walk you through our blockchain folder structure, key files, and how everything fits together for a modular blockchain integration solution. At the root of our project, you will see several folders for this demo. We will focus on the blockchain and the backend folders, which are the heart of our decentralized energy trading platform. The blockchain folder contains all the smart contracts, deployment scripts, and configuration files. We will use the latest Hard Hat framework for development and testing. Here, you will find Solidity contracts for our wallet creation, energy trading governance, and compliance. Each contract is modular, making future back-end integrations seamless. Just call the relevant functions. The backend folder handles API endpoints and connects directly to the blockchain.
Now let's test our blockchain functionalities. So here is a comprehensive testing option. Let's get started with the wallet creation. So option 1 is wallet creation for prosumers. So as we can see, I have created a wallet with KYC. The wallet address is given here and the permission for all the functionalities of the users. Now we can test the validator registration. So let's try option 4. So we can see that the validator is registered successfully and registration time, stake amount and everything. Now let's test option 5. Option 5 is governance proposal creation. You can see that the proposal is created. Now let's test the active proposal retrieval. Option 7. We just created one active proposal and that is displayed in here. This token minting for energy production. So the token is minted. You can see all the details over here. The prosumer, the address, the amount, so the token being minted, transaction, hash and everything. You can also see here that the minting has happened. So the token mint. Now let's try sending an offer. So let's type option 9. As you can see, an offer is created with address from address tag and the transaction hash you can see over here. Transaction hash can also be displayed in here. We have created an offer. It's the offer that we created. Now let's see the active marketplace as we just made a sell offer. So there is one two offers currently listed. Now let's test option 10. We will try to buy energy. So as we can see, we have successfully bought energy. We can also see that over here that the gas used, the value of it, and the block, the transaction hash and everything.
Our AI ML modules are built with Python, leveraging frameworks like TensorFlow and Scikit-learn. These models handle fraud detection, dynamic energy pricing, and demand forecasting, ensuring the platform remains secure and efficient.
Here we have multiple models. We have the model for anomaly detection, which detects anomaly in energy through the smart meters, and if there is any tampering, we can detect the anomaly and prevent the frauds. We have demand forecasting, which can forecast demand from their data from weather and historic data, and we can forecast the demand. There is dynamic pricing, where we put on a dynamic price with the help of historic data and forecasted data. We can optimize energy for better and greener energy, and we are using API to use these functionalities. So let's try running the APIs. First, let's try out the prediction. When I paste this, and we have to select a request body. So let's copy this and paste it over here. We'll paste it at the body. Here we have one device's information, consumption, production, temperature and everything from one device, one smart meter. We can put different meters in here. Multiple meters can be added like an array, and if we send this to the API, we will get, so there is a prediction. This is the value of the prediction we have. And let's try the pricing. Pricing takes the same body. Here is what we have in return. Similarly, we can also run the anomaly. Anomaly takes a different anomaly takes the same request body. And yes, we have the same in return. And for suppose I am putting some enormous value over here, like I'm consuming 500, and let's say I produced 5,000. That will be an anomaly, and it will flag it. Currently it's flagged normal, but if I change it to some the normal value, it will flag it. So let's try running it. Here it is. It is saying that it's an anomaly. Again, we can also try the optimization. is the optimization result. We have gotten recommendation and stuff.
Thank you for watching.